Hello everyone, welcome back to my channel. So in this video we are going to learn about capacitance of parallel plate capacitor. Capacitance of parallel plate capacitor. Okay. If you are first time to my channel, please consider subscribing and hit the bell icon to get video notifications from my channel. Right, so what is capacitance first? So capacitance represented by C. So if two equal and opposite charges are separated by some distance, okay, so by some distance or by a distance d, okay, by some distance d, then they form a capacitor. Okay, so and the equation is given by C is equal to Q by V. C is equal to Q by V. So Q is total charge. Okay, so Q is total charge and V is potential, electric potential. Okay, so electric potential, right? So this is the definition of capacitance. If two equal and opposite charges are separated by some distance d, then there exists electric field between them. When there exists electric field, we can calculate the capacitance by using this formula. C is equal to Q by V. Okay, so let us take a parallel plate capacitor. Let us take a parallel plate capacitor. Okay, so this is the parallel plate capacitor. This is the point Z is equal to 0. So, and this is the point Z is equal to D, and this is the point Z is equal to minus D. Let us take this as origin. So this is totally having the positive charges, and this parallel plate, okay, parallel plate capacitor consists of two plates, right? So this is negative resistance. So here the total charge density is rho s, okay, total surface charge density is rho s. So here it is minus rho s when this is plus rho s. Okay, due to positive charges, this will be equal and opposite, so it will be minus rho s. Okay, let this be surface 1 and let this be surface 2. So direction of electric field always starts from positive charge and ends on negative charge. So this is the direction of electric field. Okay, so this is along Z direction. So this is along Z direction. So this is Z is equal to D plane, and this is Z is equal to minus D plane. And total surface charge density is rho s here, and total surface charge density is minus rho s here. Okay, so now let us find the capacitance. So capacitance is given by Q by V to 1. Okay, so Q by V to 1. Right, so first of all we need to calculate Q. Okay, right, so what is Q formula? So when surface charge is there, it is rho s ds. Q is equal to integral S rho S ds. So this we have already seen. So this can be written as rho S integral S ds, right? So ds bar, of course. So this is total surface charge. So total surface charge, so total surface area. So distribution of surface area is along the parallel plate, right? So distribution of this charge is along the parallel plate. So total surface can be written as the area of the parallel plate. So how much distribution is there? Okay, so how much distribution is there of these positive charges on this particular parallel plate capacitor is given by the total area of this. Okay, total area of this parallel plate. So I have taken it as A. Okay, total surface area is equal to the total area of the parallel plate capacitor, right? So that is Q. So Q is equal to rho S into A. So once you got Q, you can calculate E bar. So how to calculate E bar? So for this, this is a parallel plate capacitor with finite surface charge density. So I have already given you the formula for surface charge density, rho S by 2 epsilon naught into AN cap, where AN cap is normal. Okay, so normal vector. So here there are two parallel plate capacitors. So one is positive parallel plate capacitor, second is negative parallel plate capacitor. So for positive parallel plate capacitor, the plane is Z is equal to D. So Z is equal to some positive plane. So when Z is equal to D, positive plane, so what is its normal? So normal is given by rho S is positive here, so plus rho S by 2 epsilon naught. So Z is equal to D plane, so we'll write here minus AZ cap, minus AZ cap. And for a second parallel plate capacitor, so for this parallel plate capacitor, so what is the formula? Rho S by, so here it is minus rho S, because the surface charge density is minus rho S. So minus rho S by 2 epsilon naught into AZ cap, because this plane is Z is equal to minus D plane, so its normal is a positive plane, so it is AZ cap. So it will be minus rho S by 2 epsilon naught into AZ cap minus rho S by 2 epsilon naught into AZ cap. So it becomes minus rho S by epsilon naught into AZ cap. So this is your E bar. So what is the rho S? So how can we write rho S from this equation? So from equation 1, how can we write rho S? Rho S is equal to Q by A. So this can be written as minus Q by A epsilon naught into AZ cap, volt per meter. Okay, so this is the value of E. So we know that from the previous video, so we know that V21 is equal to minus integral 2 to 1. Okay, so VAB is equal to A to B, so V21 is equal to 2 to 1 E bar dot DL bar, E bar dot DL bar. So now length is along Z axis, so we have dz here. Okay, so DL is equal to so we are talking about only Z axis, so DL bar is equal to dz AZ cap, right? So minus 2 to 1, minus 2 to 1. So what is E? E is this one, so minus Q by A epsilon naught, Q by A epsilon naught AZ cap dot DL bar. DL bar is dz AZ cap. Okay, so what is the distance here? So dz is the distance, right? So we'll write one more step, 2 to 1. Okay, so 2 to 1 minus Q by A epsilon naught into dz. So here integration is with respect to Z, right? So this capacitor, this 2, that is the second parallel plate capacitor, is at origin. right? So is at origin, and here it is this first parallel plate capacitor is at distance d. Okay, so at these points, if you talk about that starting point, I'm talking about the starting point. So this is the total distance, this is dz, right? So the integrations will now be from z is equal to 0 to z is equal to d. So in order to integrate dz, so the integration is from z is equal to 0 to z is equal to d. So it is from z is equal to 0 to d. So there is a minus sign here, sorry. So minus q by a epsilon naught into dz. So minus into minus will become plus. Okay, so q by a epsilon naught, all are constant. So integral of dz is z, and limits are from 0 to d. So it becomes qd by a epsilon naught. So this is your V21 volts. So if you want to calculate the capacitance of parallel plate capacitor, capacitance of parallel plate capacitor, it is q by V21. Q by V21. So Q by V21 is QD by A epsilon naught. So Q and Q gets cancelled. So it will be A into or epsilon naught A by D. Okay, so C is equal to epsilon naught A by D farads. Okay, so this is the formula. So formula for capacitance of parallel plate capacitor is given by C is equal to epsilon naught A by D farad. Okay, so just have to remember this formula, right? So consider how we have got this. So capacitance is two equal and opposite charges separated by distance d is called a capacitor. C is equal to Q by V is the formula, right? Q is total charge and V is the potential difference. So two parallel plate capacitors I have considered. So one is at origin, right? So starting point is origin, other is at Z is equal to D. So that becomes your dz, and the surface charge density of positive charges will be plus rho s and negative charges will be minus rho s. So based on that I have calculated E bar, that is electric field intensity. So once you got electric field intensity, and we are going to calculate potential. So once you got potential, you can substitute in this formula to get the capacitance of parallel plate capacitor. So that we have obtained it as C is equal to epsilon naught A by D. Okay.